Welcome to my YouTube channel Math Sikshak. I am a mathematics teacher with 15 years of teaching experience. I have been preparing students for CBSE, ICSE and IGCSE board examinations. During this journey, I have realized that mathematics needs to be taught in a simple and meaningful manner. It is my endeavor to present a topic step by step in a simple manner. I have tried to correlate the problems with real life examples. In this video, I will be explaining about radicals or surds. At the end of this session, you will be able to understand the term radical or surd, link surds with the laws of indices, to simplify a surd, addition and subtraction of surds, multiplication and division of surds. My presentation is divided into 4 parts: an introduction, followed by an explanation. Few questions have been solved step by step, and in my final section, I have a set of questions with answers given. For any clarification, you can mail me at mathsikshak@gmail.com. In my previous video on exponents, I had introduced the term surd. Now let us clearly understand what is a root and what is a surd. Now what do we see here? X is a base. It is raised to the power of 1 by n. Nth root of x means x to the power of 1 by n. So when the base has a fractional power, it leads to either a surd or a root. Now, when is nth root of x called as a surd? It is a surd of order n when nth root of x is irrational. That means it is a non-recurring decimal. Let us clearly understand this with an example. Now I take cube root of 5. I call this as a surd of order of 3. Why? Because cube root of 5 is a non-recurring decimal. Its value is approximately 1.70998. It keeps moving on. So therefore cube root of 5 is called as a surd. Now I take root 16. When I take root 16, its value is 4. So I get a perfect value. Then root 16 cannot be called as a surd. Then 4 is called as a root. Now when I take a surd, root 5, this is a surd. Then 5 is called as the radicand, and the sign, root sign, is called as the radical sign. Now let us try to understand why is the knowledge of surds so very important. Now, from the application of Pythagoras theorem. Now we use Pythagoras theorem to measure distances, to calculate heights, and so on. So from the application of Pythagoras theorem till designing of bridges, surds are very, very useful. Even a small change in the decimal expansion will change the structure of the object. Therefore, the knowledge of surds is very, very important. Proceeding further to our next section, that is the explanation section. Here I'll be discussing about simplifying surds to simplest form and the various operations on surds. Surds as indices. Now let us see how the law of exponents are also being applied here. As I'd already told, nth root of x means x to the power of 1 by n. Root over xy is equal to root x into root y. How? Root over xy means it's xy to the power of half. So when we apply the same power law says ab to the power of p is a to the power of p into b to the power of p. So similarly here, xy to the power of half is x to the power of half into y to the power of half. That's nothing but root over xy is root x into root y. Similarly, root over x by y is root x divided by root of y. In my next slide, I'll be discussing about how to reduce surds to its simplest form. Step 1, we should break it into its factors. We should make sure that we break it as a perfect square, highest perfect square into another factor. Why do we do it? To make our simplifications easier. Step 2, we will apply the law of indices, and step 3, we will simplify. With a few examples, I will be able to illustrate the steps clearly. Example 1, simplify root 27. So it is root over, my highest perfect square there is 9. So it's root over 9 into 3. Applying my law of exponents, I can break it and write it as root 9 into root 3. Root 9 is 3 into root 3. So that's equal to 3 root 3. So step 1 was breaking into its factors. Step 2 was applying the law of indices. Step 3 is simplification. Example 2. Simplify root 99. Again, step 1, breaking into its factors. So we write it as root over 9 into 11. Step 2, applying the law of indices. So it's root 9 into root 11. And step 3, root 9 is 3. So it is 3 root 11. Now, let us understand how do we add and subtract surds. Step 1, we should always make the radicals the same. Step 2, we will add or subtract their coefficients. And step 3, we will combine them. Now, with a few examples, let me illustrate these steps clearly. Example 1, root 54 minus 5 root 6. So step 1 was bringing them to the same radicals. So we simplified to its simplest form. So root 54 is root over 9 into 6 minus 5 root 6. So we can again split this further by applying the law of indices. Write it as root of 9 into root of 6 minus 5 into root of 6. So root 9 is 3. So it is 3 root 6 minus 5 root 6. That is, we will now combine the coefficients together and write it with their radical. So it's 3 minus 5 root 6. That is minus 2 root 6. Example 2. 8 into root of 242 minus 5 root 50 plus 3 root 98. That is 8 into root over 121 into 2 minus 5 into root over 25 into 2 plus 3 into root over 49 into 2. That's equal to root 121 is 11. So it's 8 into 11 into root 2 minus 5 into 5 into root 2 plus 3 into root 49 is 7 into root 2. 8 into 11 is 88. So it's 88 root 2 minus 25. 5 into 5 is 25. 25 root 2 plus 7 into 3 is 21. 21 root 2. That's equal to root 2 into, we are combining all the coefficients. So it's 88 minus 25 plus 21 into root 2. That's equal to 84 root 2. Now let us understand how do we multiply and divide surds. First, we will multiply and divide the radicals. Next, we will multiply and divide the coefficients, and then we will combine both of them. My next few examples will clearly illustrate the steps. Example 1. Simplify 5 root 7 into 3 root 14. So we'll multiply the coefficients separately, multiply the radicals separately. So 5 into 3, 15, root over 14 into 7. That is 15 into root over 98. Next example, simplify minus 3 root 12 divided by 2 root 2. So we take the coefficients separately and radicals separately. So minus 3 by 2 into root over 12 by 2. That's minus 3 by 2. Root over 12 by 2 is 6. So that's minus 3 by 2 root 6. Now proceeding on to our solved questions. Simplify 4 root 28 divided by 3 root 7. So it is about multiplication and division of surds. Multiply or divide the coefficients separately. Multiply or divide the radicals separately. Since here it's division, so it will be 4 divided by 3 to root over 28 divided by 7. That is 4 by 3, root over 28 by 7 is 4. So it's 4 by 3, root 4. That is 4 by 3 into 2. That is 8 by 3. Next question. Evaluate root 10 into root 15. This is again about multiplication of surd. So radicals separately, coefficients separately. Here the coefficients are 1. So it is root over 10 into 15. That's root over 150. That is root over 25 into 6. That is root 25 into root 6. That is 5 root 6. Find the value of root 8 plus root 18. So here we use the addition and subtraction of surds. What did we say there? Bring them to the same radical. Then we group them. So root 8 is root over 4 into 2 plus root over 9 into 2. So applying the law of indices, it is root 4 into root 2 plus root 9 into root 2. That is 2 root 2 plus 3 root 2. We brought them to the same radical. Now we will group. So it becomes root 2 into 2 plus 3. That is 5 root 2. Now let us see what are the common errors that is usually done when we simplify surds. Root x plus root y is not equal to root of x plus y. So whenever there's an addition sign, it can never be separated within the roots. The roots can never be separated whenever there's an addition sign between the two terms. Similarly, root x minus root y is not equal to root of x minus y. It's only possible for multiplication and division. Root of x plus y by x minus y. We cannot cancel the x and we cannot cancel the y here. We cannot do that with the numerator and denominator. And saying that to be equal to 1 is completely wrong. So we need to be very careful. Only with multiplication and division can cancellation in numerator and denominator happen. Moving on to our last section, that is the unsolved section, where few questions have been given with answers. For any clarifications, you can mail me at mathsikshak@gmail.com. gmail.com. For any suggestion, feedback or queries, please contact us at mathshikshak@gmail.com. Thank you for watching Math Shikshak. Kindly subscribe to my YouTube channel for further updates of my upcoming videos. Thank you.